Neural radiance field, or NeRFs more familiarly, are these kinds of deep learning tools to represent 3D scenes. NeRFs actually get used to create these images with this technique called volume rendering. Volume rendering shares some similarities to these ray tracing techniques we see in modern video games. The standard way is to shoot out these rays at randomly selected pixel locations to get a good coverage overall of the scene. We have to place these 3D point samples quite densely along the ray, because in the beginning we don't have any clue where the objects are located or what color they are. So it's quite easy to imagine that in case of millions of pixels in terms of high resolution images and possibly hundreds of samples along the rays, this process can become quite computationally taxing. We develop a way to speed up this process of encoding the 3D scene information into the NeRF network parameters. And it all starts with this intuition that there is likely variance in the difficulty of objects in the 3D scene, meaning that most likely some of the objects are easier to learn to capture correctly. The developed method allows us to do this dynamic detection of these hard objects and focus the computational resources on learning them. This enabled focus on just the hard samples actually means that we can achieve the same quality in less time. And since we don't have to train the NeRF model based on all the samples, we actually save quite a bit on the device memory usage as well. These kinds of speed up and memory reductions already have the ability to bring the NeRF models available to a wider range of lower-end devices.